Hi everyone, let's see theoretical and experimental yield. So whenever we do an experiment, we don't necessarily get the mass of products that we were expecting. So the amount of a product that we are expecting is called the theoretical yield, and the mass that we get when we do the experiment is called the experimental yield. So normally when we do the experiment, the amount of product that we get is usually less than what we expect to get. And there are many factors that contribute to this reduction of yield. One is impurities. Sometimes the reagent that you're using contains impurities in them. So let's say you're burning magnesium. So the sample of magnesium is not 100% magnesium. So there's other impurities in that. So if you're burning less magnesium that you thought you had, so you're going to get less product. The second factor is incomplete reactions. So, for example, if you are burning magnesium and you are twisting the magnesium ribbon into a coil and you're burning it, maybe the inside of the coil is not going to burn properly. So you have incomplete reaction. So if you thought that 2 grams of magnesium burned completely when actually only 1.2 gram burned, for example, because of incomplete reactions. Another factor is practical losses that occur during the experiment. For example, let's say you're pouring or you're filtering the product. During filtration, you can have some of the product that is lost. Or if you're pouring some of maybe if it's in a powder form, some of it can get lost as you're pouring it. Another factor is side reactions. These are unwanted reactions that compete with the desired reaction. So the actual yield is normally always less than the theoretical yield. So the theoretical yield is what you're expected to get, and we get this value only from calculations. And these calculations are done using the chemical equation of that reaction, and we will be using mole ratios to calculate how much you are expected to get. This theoretical yield, this is obtained from stoichiometric calculations. So the theoretical yield, this is 10 grams, and the experimental yield, so after carrying out the experiment, only 8.4 grams was obtained. So therefore, the percentage yield is going to be 8.4 divided by 10.0 times 100. So that gives me a percentage yield of 84%. So I'm getting only 84% of what I was expecting. So this is the percentage yield. Let's try another example. So here you have iodine 5 oxide reacting with carbon monoxide, and you're given the mass of iodine 5 oxide and the mass of carbon monoxide. And since you're giving the mass of both of them, it means that you'll have a limiting reagent. So you'll need to find the limiting reagent so that we can find the mass of carbon dioxide that we're getting. So this is the product, and I need to find how much product I'm expecting to get, the theoretical yield of the product. So how much product is being expected. So first I'll find the limiting reagent. I'll convert mass to moles. So I've calculated the MR of each of them and number of moles of each of them. So from the number of moles and from the mole ratio, I'm going to get the limiting reagent. So mole ratio is 1:5. And I divide the number of moles by the mole ratio. So this is the smaller number. Therefore, CO is limiting. So I've just done the calculation to find the limiting reagent. Okay, so this calculation, the values that I get from this calculation is not going to be used anywhere else. It's just used for me to get the limiting reagent. So I found that CO is limiting. From this, I can now get the number of moles and then the mass of carbon dioxide. So then from equation, I know that 5 moles of carbon monoxide gives me 5 moles of carbon dioxide. So based on the mole ratio, so 5:5, therefore 1.2 mole of carbon monoxide will give you 1.2 moles of carbon dioxide. Now from the number of moles of carbon dioxide, I can get the mass of carbon dioxide. Mass is number of moles times mR. So 1.20 times 44.01, so that's 52.8 grams. And the mass here, or the masses here, they were given to 1 dp. So I'm giving my answer to 1 dp as well, right? So this is the mass of carbon dioxide that I'm expecting to get. So I did stoichiometric calculations. All these are stoichiometric calculations for me to find the theoretical yield, how much I'm expecting to get. Given an experimental yield of 0.9 moles of carbon dioxide. So this is what we got experimentally. So let's calculate the experimental mass. Experimental mass is number of moles times mR. So this is the mass that we actually got when we did the experiment. Therefore, the percentage yield is going to be the experimental mass divided by the theoretical mass times 100. So that's going to be 39.6 divided by 52.8 times 100. And you get a percentage of 75%. Now, you can also do this calculation of percentage yield using the moles. So you can do experimental moles, which is 0.9, divided by theoretical moles, which is 1.2, and times 100. You can also do that. It gives you the same answer. Right? So this is experimental yield.